Welcome back, geometry students. This is part 2 to the quiz review for sections 5.4 and 5.5. For exercises 1 to 5, refer to triangle HGF. You notice this is a special right triangle, a 30, 60, 90 triangle. So the general form, or the general pattern is, the short leg is x, the longer leg is x times the square root of 3, and then the hypotenuse is 2 times x. And for number 2, just to make it a bit more fun, I changed the h to an f. So number 1, f is equal to 2 times the square root of 3. In this problem, they give us the longer leg. To go from the longer leg to the shorter leg, we divide by the square root of 3. 2 root 3 divided by the square root of 3. The square root of 3's cancel out, and I find that my short leg is equal to 2. To go from the shorter leg to the hypotenuse, I multiply by 2, so I find that the hypotenuse is 4. For number 2, if f is 12, remember, f is my longer leg. To go from the longer leg to the shorter leg, we divide by the square root of 3. However, I can't leave my answer like this. I have to rationalize the denominator by multiplying top and bottom by root 3. So I have 12 root 3 divided by 3, and you'll notice that the 12 and the 3 cancel out. 12 divided by 3 is 4, so my final answer is 4 root 3 for the short leg. And then to go from the short leg to the hypotenuse, I multiply by 2. 4 root 3 times 2 is 8 root 3. I'm going to work out problems 3 through 5, and then you can check your answers with mine. Here are the answers that I got for the remaining sides in 3, 4, and 5. Next, we're looking at a 45, 45, 90 triangle. So the pattern is the two legs are the same, they're both x, and then the hypotenuse is x times the square root of 2. For number 6, they tell us that this leg is 3. Both legs are the same, since 45, 45, 90 is an isosceles triangle. So the second leg is also 3, and the hypotenuse is 3 times the square root of 2. For number 7, this time they give us the hypotenuse. To go from the hypotenuse to the shorter leg, we divide by the square root of 2. 9 divided by the square root of 2, but I can't leave my answer like that. So I multiply top and bottom by radical 2, and my final answer is 9 radical 2 over 2. There's no way to simplify the 9 over 2, so I'm just going to leave it that way. 9 root 2 over 2 is x, and since it's an isosceles, 9 over root 2 is also w. And these are the answers for 8, 9, and 10. Notice for number 9, the hypotenuse was 14. To solve for this side length, I divide by root 2, but I couldn't leave my answer 14 over radical 2, so I multiplied top and bottom by radical 2, and I found 14 root 2 over 2, and then I simplified the 14 over 2, and my final answer was 7 root 2. Number 12, they tell us the measure of angle BAC is 45. Since this angle is 90, I know that this is a special right triangle, a 45, 45, 90 triangle. They give us one of the legs. To go from a leg to the hypotenuse, I multiply by the square root of 2. So the hypotenuse is 4 times the square root of 2, which is AC in the figure. Next, they want us to find AD. The other piece of information they tell us is that the measure of angle D is equal to 30 degrees. Since measure of angle DAC is 90, that makes this a 30, 60, 90 triangle. We know the short leg of this 30, 60, 90 triangle is 4 times the square root of 2. To go from the short leg to the long leg, we multiply by the square root of 3. And 4 root 2 times the square root of 3, remember you can only multiply the numbers in the radical together. So AD is 4 times the square root of 6. Next we're going to find CD, which is the hypotenuse of the 30, 60, 90 triangle. To go from the short leg to the hypotenuse, we multiply by 2. This time I'm going to multiply the 4 and the 2 together, and I find that my hypotenuse is 8 root 2. We're almost done. Triangle ABC is an equilateral triangle with a side of 6. I'm going to make this guy a little bit bigger so we can see. So here's my equilateral triangle. They want to find the altitude to one side. So remember, the altitude connects the vertex to the opposite side, and this side is perpendicular. In order to solve for the altitude, I'm going to look at this like a right triangle. We actually know two sides of this right triangle. The hypotenuse is 6, and the shorter leg is 3 because it's half of this side. So we're solving for the altitude. Let's call it B. There's two ways to solve this. You can either use your special rights and notice that this is the long leg in a 30, 60, 90 triangle, which would make the altitude 3 times the square root of 3. If you didn't notice that this was a 30, 60, 90 triangle, you could also solve this using the Pythagorean theorem. A squared plus B squared equals C squared. Plug 3 in for A, and plug 6 in for C. So I have 9 squared plus B squared is equal to 36 squared. And I get B squared is equal to 27. When I take the square root of both sides and then simplify this radical, I get the same answer I got before, 3 times the square root of 3. Next, they want us to find the area of the triangle. Area is equal to 1/2 base times height. Remember, we're finding the area of the entire triangle. So the base now is 6, and the height is that 3 root 3. An exact answer would be 9 root 3, but I would actually like the approximate answer, which you would find in the calculator. And I get 15.59 units squared. Lastly, number 14, find a square, or they want the area of a square with a diagonal length of 8 root 2. So I'm going to draw a square and label my diagonal as 8 root 2. Remember, the diagonal of a square bisects these angles, and if you bisect a 90-degree angle, these are both 45. So I have a 45, 45, 90 triangle, and I know the diagonal is 8 root 2. How do you go from the hypotenuse to a leg in a 45, 45, 90 triangle? Well, you divide by the square root of 2. My square root of 2's cancel out, and I find that this side is 8, and since it's an isosceles triangle, this side must also be 8. The formula for the area of a square, base times height, and I find that my area is 64 units squared.